probabilities.com. Today we do a video on a statistics lab. Let's go to the class homepage through my office page. Here's the statistics link. We're working on a lab for Friday, the 28th of February. It has to do with law of large numbers. It is a spreadsheet, and I'll show you how to open the spreadsheet. It's here, but I have mine already on my computer. So I'm just going to open mine and refer to the material on the web page, which is available in PDF form, and we're recording the video now. There are certain things you already as a class know how to do that have to do with a spreadsheet. We're going to use some of those and go on to some new ones. I have coded by color and told you which step to do first. And the first thing we're going to do is we're going to pick up, copy, select, and paste from this web page the column headings of rows 4 and 5. So we're going to put all this stuff, which you can copy right here. It's laid out as a table. You just want to copy what's in the table. And I'm hitting Control-C to copy it. I'm going into the spreadsheet, and here are the instructions, and here's where we have to paste it. This is a sample of what you're about to do, and here is where you will paste what you need to do the assignment, and then we're going to make it a little better looking. And it's in 2 columns, 2 rows, so I'm just going to block that off and adjust the height a bit. And tell the computer I want everything in the middle. It doesn't always understand what I want. I don't explain it sometimes very well. Okay, we have now done step 1. And I won't be referring to this. I'll be referring to the web page. I think it's easier to read. And it is also color-coded. So we have finished pasting the red headings. That was step 1. Now we're about to do step 2. In cell N6, place the number 1 for the first coin toss. Right here, there's the number 1. That will be the beginning of a counter. Next step, yellow, will be to select a way to number all the rows. Your textbook calls it experiment. I prefer to call it coin toss or trial number. Each toss has to be numbered to make it easier to create a scatter plot later. So I'm sitting on cell number 2 here in yellow. And according to the website, in cell N7, type equals. What equals does is it begins a formula. Then click on cell N6, then type +1, and then just hit enter. So we're going back to the spreadsheet, and I already did this for you. I'm going to show you how to do it. The goal is to get all those numbers. So I'm going to sit on this cell, and I'm going to tell it equal. I have a formula I'm thinking of. I want it to take the value here and add 1 to it. And I get 2. Now I'm going to copy that cell with the Control C, and I'm going to paste it 500 times. Your book suggests using 500. I think 350 is more than enough. I think 10 would be fine, but it doesn't give too good a scatter plot. So I'm doing what the book recommends, and I'm going with 500. I'm going to hit Control V, and it's pasted it. So far, I think you're fine. Next step, I want to make these numbers not formulas. I want to make them constants. So I'm going to select everything I just had. And I'm going to hit Control C to copy it. And I'm going to go over here underneath the file into paste. I'm going to hit paste, and I'm going to paste a value. And now instead of being a formula, I have just a number. For the last assignment, I already did that for you. We'll do this assignment now. So the next step looks like it might be that color or this color. We'll see what comes next according to the web page. Okay, sit on cell N7 and copy. We did that. We did the green one. Now we're on the 5th step. In cell 06, use the type symbols and code on the web page. Copy, then paste the following expression. Now, I can't pick up this expression here because it's an image file. So up here, I put it so that you could copy it. Before I copy it, let's look at what it says. It says you do innermost first, just as order of operations. And this has a few different layers of innermost first. This says you're going to use the number 0 and the number that's a little bit bigger than 1. And you're going to generate a random number between those two numbers. Then you're going to round it, which means round it either to 0 or to 1. So I've selected that off the web page. I'm going to pick it up with a Control C. I'm going to go into the spreadsheet, and this is the color I want. I'm going to paste it with a Control V, and it gave me a value for this command. I'm going to sit on that button, press Control C to copy it. I could have done it in one step. I'm doing it in 2. And again, I'm going to paste everything. What I'm doing is I'm generating 500 coin toss results. It's as if I had a fair coin. Fair coins have equal chance of getting a head and a tail. And I'm going to flip all those coins, 500 coins at once, and see what I get. If it's a 0, I got a tail. If it's a 1, I got a head. I'm pressing Control V, and I have a whole bunch of numbers here. And I think I'd like to line them up so they're in the center. Don't have to do that, it just looks nice. And I'm going to pick up all the numbers. And once again, I'm going to hit copy, and I'm going to go to paste, and I'm going to hit paste value, and we're now done. We now have not a formula, but a number. I think we're good so far. I don't think you have any problem. Now we go to cumulative sum. Cumulative means everything you've done already and the current. So cumulative, the first number we have to add to get the sum is right there. Oh, let's just escape from where we are. What I hit was the escape button, and it got rid of selecting. So I'm sitting in this first cell. Again, I'm going to hit an equal sign, and I'm going to go over one cell and copy that by hitting enter. So it now gave me the sum so far. I think I'm going to line this up also. What I'd like to do is I'd like to each time add the former cumulative sum and the new sum. So I'm going to hit equals. I'm going to go up into this former sum. I'm then going to tell it add, and I'm going to tell it to add that number. And 0 plus 0 is 0. I'm going to sit on this one, Control C to copy it, and then select all of these down to 500. I always go too far. There we go. And I'm going to paste them with the Control V. And I'm also going to hit escape and pick them all up again. And then we'll look at them once we do that. Control C to copy them. Paste value. And we're done. I'm hitting escape to get out of there. Let's just see if it made sense. The first 1, 2, 3, 4 tosses were all tails. Then I got a head. There's my head. Then I got another head, so altogether I have 2 heads, and another head, so I have 3. And then I got a tail, so my count is still 3. And the count keeps going up. But every time I get a tail, the count remains the same. Every time I get a head, it adds 1. Next column, running average. That means, how do the heads compare to the total number of tosses? And this time it's a division problem. We hit equal. I think I'm going to do this. I think I'm going to make all of these. Let's do it again. In this column. No, that didn't work too well. Oh, I know what I was doing because I was doing that. Okay. In this column, I'm going to make all the lettering white. And that hides these, so I have to make these 2 black. So far, so good. I can now read everything. I'm going to make this an equal sign to create a formula. I'm going to tell it I need the number of heads, which is my cumulative sum. Then I need divided by next to the shift key on the right. And then I need the number of tosses, which is experiment. And it should give me, well, it gave me a white number. I want to center it. And now, once again, I'm going to copy. I'm going to copy that cell with a Control C, and I'm going to paste it. With the Control V, I'm going to hit Escape. And I'm going to select everything. Oh, I missed again. Control C to copy it. Go into paste, paste it, hit Escape. I now have numbers instead of a formula. Notice the first few are all zeros because 0 divided by 4 is still 0. Here I have a 1. 1 divided by 5, well, it looked like it rounded this. Let's just up it 1. Ah, that is 1/5. 1 divided by 5 is 2 divided by 10. Here we have 2 out of 6, that's a third. 3 out of 7, there we go. We're now at the point where we can create a scatter plot. I'm going to shrink this column. I'm going to shrink that column. And in order to do a scatter plot, I have to insert it. In order to insert it, I have to select 2 columns. I'm going to cheat. I'm going to go to this column. No, I'm going to go to this column and I'm going to add column. Insert a column. What I'm then going to do is pick up all my numbers with the Control C and go sit in column P and paste it with a Control V. Now I did that not because I'm wise, but because it was suggested in the department's lab manual for this lab. We're not using their lab because, according to college policy, I can only require that you have free material, free software. When I attempted to use the college's lab manual, it had a tool, this is where they stick tools, that I could not download or find on the web. So because of that, I wrote this spreadsheet, and the next sheet will continue with the lab. But it suggested that I put the 2 columns together. The reason it suggested that is, you remember from our last lab, I have to select both the X and the Y. These are the X's, these are the Y's. So I'm going to sit on the 1 and stretch it to the 2, stretch it to the 0, the Y value, and I'm going to copy it all the way down. I'm getting better. Okay, so far so good. I have 2 columns copied. I'm going to go to Insert, and I want the scatter plot, and I want to choose it. Now, we did this last lab, and I found out a nice little trick. I'm going to go sit on the chart, and I'm going to cut it out with a Control X. And then I'm going to move up here. To an area I already highlighted. And I'm going to sit in the black and hit a Control V. And now I have the chart. I'd like to look at 2 things. First, you see that nice wiggly line. You know where it came from, but maybe not consciously too much. I'm going to take these numbers and just so they're easier to read, turn them into a 4-digit decimal number. Notice the numbers hover close to 0.5. I start out with zeros, that's down here. I have a whole bunch of them, then I go to 0.2, 1/3, and so on. And what happens is the numbers get more similar. There's less of a variance. And the line here is the 0.5 line. Here's 0.4, here's 0.3. Let's see if the numbers, as we go into the higher numbers, get closer and closer to the theoretical probability. The theoretical probability, I believe you already know. If you have a fair coin and toss it, there are only 2 possible outcomes, either heads or tails. And if it's a fair coin, it's not weighted in any way, then we should get close to half. So let's see if these numbers, looking at the numbers rather than at the table, they bounce a bit, but they look like they're getting closer and closer to 0.5. Here it's a little above, here it's a little below. Still below, still below. We're at 150. Getting closer to 5.5. Here now we're above 0.5, below 0.5, still below, above now, wiggling close to 0.5. So we're about 0.5, which is the theoretical probability. So the law of large numbers says for large numbers, the experimental probability, the experimental computation probability is what mostly it is, goes to or approaches the theoretical. And you have a 0.5 here, your spreadsheet changes the scale. That may be a problem in the future. Your goal, according to the web page, and all the instructions are there, is to create that scatter plot doing just what we did. Notice on this scatter plot, the average, the probability is 0.5 also. Other things that you use the paste, which is below File. In Home, you'll find Insert, and in Insert, you'll find a scatter plot. Page labels we did not talk about. Let's talk about that now. I'm going back to the spreadsheet. I have numbers down here for each page. I'm going to hit the plus sign and that creates another sheet. And I'm going to click on the tab, go up to rename, and let's call it Oscar. Why Oscar? That's all I could think of. I typed it, I'm hitting enter. Now that sheet is named Oscar. I'm not even going to do anything with it. I'm back to the lab we just created. The college version of this requires another question, and I have the symbols P and Q. I'm hitting that page. I'm going to do this for you unless you wish extra credit on your lab. If you wish extra credit on your lab, I suggest that after you've finished creating the table we just created, which is what your lab is supposed to be, you'll earn the credit for that. And then if you wish extra credit and it is not required, after you've created this and you know that you can stop the video and do the computation right there because you have the spreadsheet, and you can do it on a blank empty spreadsheet, the instructions still work. So now if you want extra credit, you create a page or sheet called P and Q, and we're now going to build this table. So just as I went through the lab before with you, I'm going through this with you also. First thing I'm going to do is I'm going to get rid of this. No, I'm going to leave it there. Okay, I changed my mind. I'd like to talk about P's and Q's. We talked about a fair coin, and that if the coin is fair, you either get a head or a tail. In this picture, instead of having heads and tails, I have P's and Q's. P is the normal symbol for probability. Usually lowercase p, you'll get a number. Uppercase P you'll use for an event of. Doesn't always follow that way, but P here stands for some number, and Q stands for some number. And it will always be true that the sum of all the outcomes has to be 1, the probabilities of all the outcomes. So what this says is if P is 1, it means it has to happen. Probability is 1, it has to happen. The probability that it doesn't happen, that it happens, is 0. So the two of them have to add up to 1. Here in this case, it says it's going to happen. Here in this case, it says it's not going to happen. If they were heads and tails, there would be 1 head and no tails. If the probability of getting a head is 0.9, that means getting a tail is 0.1. If the probability of getting a head is 0.8, that means the probability of getting a tail is 0.2, or you could look at it another way. If the probability of getting a tail is 0.3, then getting a head is 0.7. And I think that's clear enough. So what we're looking at now, if I can find the slider, there it is. What we're looking at now is we're looking at a table in which I can change the probability. And I've chosen to do it this way because I want to be consistent with what I did before. I'm just going to slide this over. Oh, I guess it's over all the way. Here's A, here's B, C. Okay, this is different and also the same and consistent. I, in the past, used a yellow cell to indicate it's a formula and don't do anything with it. Oh, this should be yellow, and this one should be white, so that here I'm asking you to enter Q. Q is the probability that you get a tail instead of a head. You know the probability of getting a head is P. That's what it was last time. That's what it was earlier. The probability of getting a tail is the complement of that. 1 minus P is Q. Here I'm setting, permitting the user to enter Q. Q is the tails. Why did I go differently? Because I want the numbers less than that probability, less than 8 out of 10 tosses, 8 out of 10 heads, less than 8 out of 10 heads, to be a loss, to be a 0. So here I put a whole bunch of numbers, and I got those by a formula, and that formula was to get a random number between 0, which is impossible, and 1, which has to happen. Those are probability numbers. So I, for each one of these cells, got a random number. I put them here so that you could see what the random number was. I didn't, as we did in the first one, did all the computation hidden. Here I laid it out. Oh, wrong one. P's and Q's. Here is the probability, and I want the probability to be 0.8 for every single trial, every single, your book calls it experiment, or every single toss of the coin. I want it always to be 0.8. I want it always to have failure 8 out of 10 times and success 2 out of 10 times, because they have to add up to 1. I did number each experiment, each trial. I went through 500, and I used the random number generator to give me a number between 0, which is impossible, and 1, which has to happen as far as the probability goes. So what this says is the number I got randomly by tossing it as randomly as the computer could generate it, flip the coin as realistically as possible. I got a 0.6805. That's less than 8. That's not enough for a success. So 0 successes. 0.2878. Not enough for a success. Not enough for a head. There it is. Here we go. 0.7. Still not enough. 0.2. Not enough. But 0.9 is enough. So we got a head. So I think you get the idea between heads and tails, P's and Q's, and why I chose to make this Q so that the number, if it came up less than 0.8, would be a 0, which meant no head. Again, I did cumulative sum. I don't remember if I copied these or pasted them. No, they're all formulas still. There's the number, here's a formula. All these are formulas still. Here's the first ratio, the first probability, the number of heads right there, the cumulative heads. And here is the number of tosses. And we have the zeros in the beginning. I then copied this column here, and I think I have to copy and paste this or things will change. I'm going to let them change. Before I let them change, I want you to look at the probability distribution here. The computer changed the scale, and I'm not going to play with changing the scale in this lab, but right here, and I can make it larger. Right here, you see it's kind of wiggling close to 0.2, maybe 0.22, 0.23. If it went further, I think you'd believe it got closer to 0.2. Does 0.2 make sense for a probability, for a proportion, for a percentage? Yes, it does, because Q was set at 0.8. Now I'm going to see if I can change everything. And I want to do it in one fell swoop if I can. All right, we're up to A. Instead of having a failure rate of 0.8, I'm going to make this 0.4. Hopefully it'll change everything. All of the probabilities for Q are 0.4. The number of the experiment stays the same. This random number, is it greater than 0.4? Yes, it is. So I have one head. This one is not, so I have 0 heads. This one is, so I have 1 head. Cumulative is given. Running average is given. The experiment number stays the same, and I copied all of these values so I could select the whole thing. Now let's look at the scatter plot. We set the failure rate at 0.4. So this is the success rate. Find the slider. The success rate, here's 0.2, 0.4, 0.6, 0.8, and 1. So if the failure rate is 0.4, the success rate is 0.6. That's to demonstrate the law of large numbers, that the experimental probability as n, or the number of trials, gets larger and larger, the experimental probability approaches, or maybe even gets to, depending on how big n is, gets to the theoretical probability. That's the entire lab. You are required to do a copy of the first spreadsheet, but I will not require you to do P's and Q's. If you do it, I will give you extra credit. If you need help, come see me in my office. You know how to get office time. Have a wonderful day.